Hi, I'm Ningshi. I'm a software engineer at VoltDB. Today I'm going to show you how easy and quick it is to import raw data into Vault and what interesting analysis you can do while the data is being imported. Before we start, let's first take a look at what we're going to cover today in this demo. So I will start by creating a schema and a project file and possibly procedures later for this demo. And once we have these three files, we can feed them into a catalog compiler and generate a catalog file. After that, we can feed the catalog to a VoltDB server. Once the server has started, we can use a CSV file loader to load the CSV data that we're going to use and then insert all the data in the file into the server. The stuff in the red rectangle is the files that we're going to create today. So let's start by defining the schema first. For this demo, we have this dataset downloaded from New York State Department of Transportation that includes the hourly traffic data from sensors across the state in the year 2008 and 2009. We have two CSV files. One of them is called 08-data.csv, the other one is 09-data.csv. The two files roughly has 10 million rows in each one of them. Each row has the following information. The first column is the traffic sensor ID. The second one and the third one are the time and date this record was taken. The next column is the direction of traffic flow. And the next one is the lane it recorded. The last number, which is the most important one, is the number of vehicles went past the sensor in the hour. To get started, we need to define the schema of the database. Let's create a DDL file. So we have the schema here. The traffic table is the one that we're going to use to store all the data that we just saw in the CSV file. And the IDX underscore traffic index is just a simple tree index on the traffic table that includes the sensor ID and the record date. The view is also on the traffic table, which does summarization for us automatically when we insert the data. Next, we need a project file before we can compile the catalog. The project file is just a simple file that describes the project to Vault. It is a simple XML document telling Vault where to look for schemas, procedure files, and how tables should be partitioned. So you can see here that the traffic table is partitioned on the sensor ID. Since we don't have any procedures for now, there is no procedures element in this file. Now with these two files written, we can compile the catalog by using the VoltDB compiler. I have a parallel directory above the current directory. So let me show you the parent directory. I have a demo directory which contains all the code that I will use for this demo, and a VoltDB-2.6 directory that contains the 2.6 version of VoltDB that I downloaded from the website. So to start the compiler, I use the VoltDB compiler command. It's called Volt compiler. And the first parameter is the directory that will contain the procedure class files later in this demo. Let's call it obj. And the second parameter is the project file. The last one is the output file name, which we will call traffic.jar. Now that we can see the catalog is compiled, Volt compiler has automatically created a procedure called traffic.insert for us because the traffic table is partitioned. This stored procedure is just a simple insert statement that we can use to insert data into that table. Now that we have the catalog compiled, we can actually start the server by using the VoltDB command. All I need is to pass it the catalog path, traffic.jar. Now the server is running. I'll switch to another tab that will start the CSV loader. The CSV loader is something that we're still working on, but it simply reads a CSV file and insert all the content in that file using a stored procedure that we pass into to insert all the data into the database. So here I have a script that will load start the CSV loader. Now I will use the CSV loader to load the data from 2008. So I pass it the CSV file and then the stored procedure name, which is traffic.insert. We can see that the CSV loader is now started loading data into the database. Now I'm going to switch to another window. We can start doing some interesting analysis on the data while it's being imported. There is a utility program that comes with VoltDB called SQL command that can be used to execute SQL statements or call stored procedures. It's called SQL CMD. Now SQL command is running. Let's first start by doing some simple queries. So assume that I'm interested in the top 10 sensors that had the heaviest traffic by day in 2008. What I would do is to select star from the view that we have on the table. And order it by the traffic count in descending order and limit 10 because I'm only interested in the top 10. Now we have the top 10 list. It's quite amazing that there were over 200,000 vehicles going past the sensor in a single day. Interesting, sensor 30291 appeared 6 times in the top 10 list. You can see here 30291 appeared 7 times in the top 10 list. It must be one of the main roads. See if that's true. Let's look at the sensors that had the heaviest traffic from the beginning of 2008. This time I will use aggregation in the selected query. Sensor ID, and then I will sum the vehicle count up as total count from the view. This time I'll order by the total count instead of the count in individual days. Yeah, I forgot the group by. So group by here should group by the sensor ID. So now we have the result. of the top 10 sensors ordered by the total amount of traffic from year to date in 2008. It's not quite right. Sensor 30291 is the last one in the top 10 list. On the other hand, sensor 50062 here, which is the top in this list, is actually twice the traffic as 30291, while it only showed up once as the last in the previous top 10 list. So let's think about it. The one that showed up most in the heaviest traffic by day is only the last in the heaviest traffic by year-to-date list. This could mean that it was rare for sensor 30291 to have so much traffic in a day. On the other hand, sensor 50062 had a much steady heavy traffic flow. To prove my theory, let's look at the top 10 list by average traffic instead of total traffic. So this time I'll change the aggregation sum into average and then call it average count. So here you can see sensor 50062 is high on the list while 30291 doesn't even show up. Let's go back to the heaviest traffic by day result for a moment. Notice the dates for sensor 30291 are all pretty close together. So they're June 19th, June 20th, June 17th, 18th, 26th, and 25th. There must be some events going on near that sensor. A little Google around, I found that this sensor was actually close to a local IKEA store, so maybe IKEA had some sales event at that time. So now that we've seen some simple queries, imagine if I'm curious to know when a road had a traffic spike. What I can do is constantly do queries to find out what are the top 10 sensors that had a traffic over a certain threshold. But that's tedious to do because I have to query that constantly and I have to prune all the sensors I've seen before. Another way to do it in VoltDB is to write a stored procedure of your own and then do put all those logic inside the stored procedure. Here I have a stored procedure that does exactly that. So we can stop the client for now and take a look at the stored procedure. I named it insert.java file. So the procedure has 4 SQL statements. One is the same as what we've seen before, it just inserts data into the traffic table. And the second one is to query the view and find out how much traffic has passed this sensor on that date. And the third one is to check in an alerts table whether we have created an alert for the sensor on that day before. If we haven't created an alert, then we'll create one for the sensor on that day. So once a sensor has enough traffic passing it on a certain date, we will create an alert. If we've already done that before, we won't create a duplicate alert. And on the first creation of alert, the stored procedure will return 1 back to the client. Otherwise, it's going to return 0. So by inspecting the return code from this procedure, the client can know immediately when a certain sensor has a traffic spike. Now, we will compile this Java file into a class file. Use the javac command pass it the VoltDB jar file, which has all the stuff this procedure needed for compilation. And we want it to output the class file into the obj directory. Now it's compiled. We need to go back to the schema and add the alerts table so that the database will create a new table for the alerts. Create table alerts. The alerts table simply has the sensor ID, which is an integer, and the record date, which is a timestamp. We will also put a primary key on these two columns. Since we've added a new table, we need to edit the project file to tell it how to partition this table. It will be partitioned the same way as the traffic table, which is on the sensor ID column. And this time we've added a single procedure. We need to add it to the project file so that Volt knows to pick it up. Procedure, and the class is procedures.insert. We've updated all the files. Now we can compile a new catalog using the same command we've seen before. Volt compiler obj project, but this time we'll call the catalog traffic2.jar. I must had a typo in the project file when we added that. There it is. This element should be called procedures instead of procedure. I'll compile the catalog again. Now we have a new catalog. This time Volt compiler generated 4 more stored procedures for us. They're all on the alerts table, because the alerts table is not only partitioned, it has a primary key on it. So we have a simple delete, select, update procedures as well. And this insert procedure is the one that we wrote. This time I will use the Csv Loader to load the data from 2009 and use our new insert procedure to load the data. Before that, I need to use the SQL command to update the catalog in the database, so it will pick up the new table and the stored procedure. In SQL command, to call a stored procedure or system procedure, you type exec followed by the procedure name and parameters. So we'll call update application catalog and pass it the new catalog as well as the deployment file, which we didn't wrote, but Volt will create a default one for you in the root directory. Alright, the database has been updated. Now you should have the alerts table. We can do a sanity check here by doing a simple select. Yep, the table is there and it's empty. Now we can load the data from 2009 using this new insert procedure. Alright, the loader is loading data into the table. Now let's take a look at the alerts table to see if we have any alerts. Select star from alerts. I would do an order by on the sensor ID as well as the record date and limit 10. We can see there are alerts being created in the alerts table, and none of them are duplicates of others. So this way I will have a immediate alert when a certain sensor has a traffic spike. Besides that, I can also see a history of alerts in this alerts table. So in this demo, we've seen how to create a simple project to load data into Vault. We've seen how easy it is to do interesting analysis on real-time data and how stored procedures can help us simplify tasks. Thank you very much for watching this demo, and if you have any questions, you can send us emails or go to our forums and post it there.